Okay, welcome to the 1/6 video. I actually am going to teach through this whole lesson this time, not half of it. I want you to pay attention to something real quick though. This has a total of 4 pages, and I already taught the first page during class. So if you want to basically fast forward in the video until you see this part, then that's fine. But if you weren't in class when we did page 1 of 1-6, then go ahead and just keep watching, so don't skip. All right, so for those who did not see page 1, I'm going to go over it real quick. This first problem is review, so it's not new. It says circle the solution of 3x plus 8 is -4. And so for that one, you might as well just solve it. It's a pretty easy problem. Maybe you can subtract 8 here and here. This gives you 3x equals -12. And then divide by 3 here and here. And this gives you x equals -4. So the correct answer is x equals -4. So I'm going to go ahead and choose this one. I'm going to choose this answer right here. Okay? Alrighty. Remember, if you need to rewind, that's fine, but I'm going to press clear ink, and then everything's going to disappear real quick. So you might have to back it up a bit if you didn't get that fast enough. You can always pause my videos, right? Okay, vocabulary builder, we have this word absolute value, and that means the absolute value of a real number is really just the distance from 0 on the number line. So for example, let's say I asked you to find absolute value 5. Well, the answer would be 5. And if I asked you to find absolute value -5, the answer would be 5. So what's going on? Why are both of those 5? So let's take a look. If you imagine that 0 is on the number line, which it is, and you go plot 5, 5 is actually right here, right? You know that. So when I say what's absolute value 5, what I'm asking you is this. I'm asking you to measure this distance right here. But that distance is 5 spaces, see? Okay, now let's try -5. If I do -5, this time you're over on this side. But if I ask you absolute value, then you're asking how many spaces is this from the origin. And again, it's 5 spaces. So when you're finding absolute value, what you're really doing is counting the spaces, you see, including like half spaces, if there's any half spaces or anything. Just basically it's distance, how far is this everything from 0. And so these always give 5 as an output. Like the answer is 5 either way. And that's why we say the absolute value of 5 and -5 both comes out to be 5. So there are actually 2 different x's that you could like plug in, and then you would still get 5 in the end. Okay, let's run through these just to make sure you understood what I was saying. When I say find absolute value 3, I mean plot this point and then simply count the spaces from there to the origin. Since there's 3 spaces here, you put 3. Final answer. Okay, how about this next one? -2. Well, -2 goes here, obviously. And then we count the spaces. From where? From that point to 0. You always count back to 0. How many spaces is that? 2. So notice it's not possible to get a negative number. You can't get a negative number because you always count the spaces and you tell me how many. That's not going to be a negative number. Okay, this next question though has another negative in it. So you see this negative right here. I want you to ignore it for just a second. We have to figure out this part of the problem first. It says absolute value of 1. Absolute value of 1. Okay, so first we're going to figure out what absolute value 1 is. That's easy. Put a dot here and count the spaces back to 0. I think it's 1. 1 space. So the absolute value of 1 is 1. Right? Okay, what about that negative that was sitting in the front? Well, that's still there. That negative is still there. See? So we got 1 when we did this inside calculation. So think of it this way. We did this yellow part, and we got 1. But the green minus sign has just been sitting there the whole time. It just didn't do anything, but it's now part of our answer, and the answer is -1. Interesting problem. This also is very similar. This problem is very similar. So this is getting a little bit messy. If you don't mind, I'm going to clear the ink so I can focus on this last one. Okay, you see this 2 right here that you need to ignore, actually, and we need to solve this problem. So first I'm going to figure out what absolute value negative 2 is. Figure that out first. So let's see, that means I'm going to go to my number line. I'll put negative 2 on here. Then I'm going to count the spaces. Doot, doot. I think it's 2 spaces. So basically this is 2. That's what it is. All right, now that goes where the green is. But you see there's still a yellow 2 there also. So basically I have a yellow 2 multiplied by a green 2 like this. And the answer is 4. It takes a little bit of practice to realize when do we keep the negative and when do we not keep the negative. So let me say a word about that real quick. If the negative is on the inside and there's just a single number on the inside, you could just throw it in the trash. So like this negative is on the inside, just throw it away. But this negative is on the outside, you cannot throw it away. This negative is on the inside, you can throw it away. So if the if the inside has a negative, go ahead and throw it away. If it's outside that has a negative, keep it. How about this one? Is this complete the graph? Well, this is asking you to graph x, but we don't even know what x is. So you're going to have to kind of think about this one. What number has a distance 4 away from the origin? That's what this question means. It's saying the distance from x to 0 is 4. Well, you could draw this point and say, oh yeah, that's 4 spaces away from the origin, right? It's 4 spaces away from the origin. 1, 2, 3, 4. That wasn't a very good drawing, but that's 4 spaces. Okay, so maybe our answer is x is 4. All right, but wait a minute, there's another possibility. If I told you the distance to the origin is 4, you might also conclude that I'm talking about this dot over here. Why? Because that dot also is 4 spaces away from the origin, you see. So basically, this is also 4 spaces. So wait a minute, the distance is 4 gives me 2 possible x's, not 1. I don't know if x is 4 or if x is negative 4. If I make x 4 here, this statement's true. If I make x equal to negative 4 in this statement, it's still true. And so therefore, we don't know which x is the best. They're both equal, legit, valid answers. So we'll just go ahead and write them both. So the correct answer is x equals 4, x equals negative 4. It's one or the other. And then the graph is the 2 red dots, just the 2 red dots. Okay, let's look at this next one. This one you can just learn by thinking about number 6. If plus or minus 4 are both good answers to number 6, then obviously plus or minus 5 are good answers to number 7. Okay, so that one says x is equal to 5 or x is equal to negative 5. All right, that's kind of a fun one. Let's clear the ink. Okay, this next one's really fun. I want to convince you of something real quick. This just means that 3x plus 2, if you drew it on a number line, it would be 4 spaces away from 0. That's what this is saying. So imagine a number line real quick, and this is 0, and then 4 spaces away, 1, 2, 3, 4, you'll find that's where 3x plus 2 lives. See? But if that's true, then if you go 4 spaces this way, you should be at x equals 4. Isn't that true? You would literally be at x equals 1, 2, 3, 4. Or you'd be at 4, I mean, not x equals 4. So let's talk about this point right here real quick. Is this little star at 3x plus 2? Or is this little star at x equals 4? The answer is it's both. You see, 3x plus 2 is 4. 3x plus 2 in this problem is 4. Okay, so that was kind of weird. I just drew a 0 and a 3x plus 2. I counted the spaces. I believe there should be 4 spaces here. I labeled it in blue as the number line value 4, but I also labeled it in red as the second point. So I believe 3x plus 2 has to be 4. And that's my first equation. 3x plus 2 has to equal 4. Okay, but there's another way to look at this problem. when I told you that the distance from 3x plus 2 to 0 was 4, how do we know it's on the right? Maybe it was actually supposed to be over on the left 4 spaces. See, this also is 4 spaces, but it would mean then that 3x plus 2 is chilling over there, see? That's a possibility. And if that's a possibility, then that would mean that it's sitting at the -4 spot. So, which is it? Is this black star at -4, or is it 3x plus 2? It's both. So from that we conclude that 3x plus 2 might be -4. And that's our second conclusion. Like that. Okay, now, is there a faster way to get from the question to line to the first step of the work like that? Because we're still not done with this problem, but wasn't there an easier way to do it? The answer is yes. It's actually much, much easier than what I just showed you. Now that we've seen the drawing, I'm going to show you the shortcut. What you can do on an equals problem is you could basically just change the, so you have an absolute value, right? You have absolute value, you have a 3x plus 2, and this is equal to 4. What you can do is you can change these to parentheses as long as you promise to put a plus or minus here. Okay? That's the first thing you do. And the second thing you do is you write this as 2 statements. So first you write it as positive 3x plus 2 is 4. And then you separate it as a separate problem. Negative 3x plus 2 is 4. And if you think about it, you could also just basically not write this positive. This positive here is sort of not necessary. It doesn't do anything. It's just a positive 1. But this negative could really go on the other side if you want to call this -4 over here. And then you get these 2 answers. So what I'm saying is this one you could just basically erase, see? And then this other one, you could kind of just move it over to this side. And then you get the same 2 results. All right. You're going to have to go over that again, but also you can kind of memorize the conclusion. When the absolute value of something is equal to a number, then you basically just write this equals 4 and this equals -4. And that's how you get rid of the absolute value bars. Okay, I'm going to clear some space because I need more space, but now that we have these 2 simple problems, you should not have any trouble solving. So we're going to start with 3x plus 2 equals 4. We're going to do that one first. It's this problem. You're going to subtract 2 from both sides, and now you have 3x equals 2. And then you're going to divide by 3 on both sides, and now you have x equals 2/3. Final answer. Okay, let's look at the other possible problem. The other possible problem starts with the 3x plus 2 equals -4. And you do the same thing. You subtract 2 from both sides. And you end up with 3x equals -6. And then you divide by 3 on both sides. And you get x equals -2. All right, so you actually have 2 answers on this problem. And what's fun about these is actually checking them. So we got both answers. We'll put them on a number line real quick, then we'll check them. 2/3 would be right about there. -2 would be right about there. So that's your answer. By the way, you should use the word or between your answers, because if you put your finger on one of the black dots, you can only put your finger on one or the other. You can't put it on both at the same time. It's just one finger, so you have to kind of put one finger on this or one finger on this. You can't put it in both places at the same time. All right, cool. Now, let's check our answer, because it doesn't tell us to check, but it's really kind of fun to check. So what I'm going to do is I'm going to take the original problem, and I'm going to stick in my 2 answers. So first I'm going to put in that 2/3. And if you simplify this, you really do get 4 equals 4. It's very, very exciting. It really works. You really get 4 equals 4. Watch. This becomes absolute value 2 plus 2, which is absolute value 4 equals 4, and that's a true statement. Okay, now watch what happens when I try plugging in the other answer that I got. Oh, this is so exciting. Watch. Is it really true that my other answer works? Let's put in our other answer. Our other answer was a -2. This looks different at first, but now it gives us absolute value of -4 is 4. That's true. And that's the exciting part. When you get your final answers, you'll know they're right, because you could plug them right back in to the original question and you get 4 equals 4 for both answers. Very exciting. Don't forget, we always try to draw a picture, not just answer. So this is our algebraic answer, and this is our graphical answer. We try to always draw. Okay, let's go to the next example. This one's a little bit more complicated because the way they wrote it. But if we move the 3 to the other side and maybe divide by 2, I think we'll be right back in the same situation as we were a minute ago in problem 1. So first thing I'm going to do is subtract 3 from both sides, like it says right here. And that means you're going to end up with 2x, 2 times absolute value x plus 9, and then this side is just a 4. So these cancel, and the right side is now just a 4. Now I'm going to divide by 2 on both sides, so like this, divide by 2 here, divide by 2 here. And now it's a very simple problem. It's absolute value x plus 9, absolute value x plus 9 is 2. All right, and this splits into 2 equations. So like I was saying before, eventually this will just break into x plus 9 is 2, and also x plus 9 is -2. Like we were saying back on problem 1. So the equals ones are pretty easy. They just split up. Let's solve. So if we have x plus 9 is 2, and we subtract 9 from both sides, we end up with x is -7. What's that negative? 2 minus 9 is -7. And the other one was x plus 9 equals -2. And again, we subtract 9. But be careful, this is x equals -11. So we're going to plot on here -7 and -11. And we'll put an or here. X equals -7 or x equals -11. It can't be both. So there's your algebraic answer, and we've got a graphical answer. I'm not sure why they're doing this problem, maybe to show you what to do with this 3 right here. This 3 should be basically subtracted like in the very, very beginning. Otherwise, it's kind of hard to do the problem. All right, rewind if you need to. Ooh, here's one with x on both sides. Oh boy. Okay, so we've kind of learned our lesson. Having an absolute value on the left side of an equals sign is pretty much the same thing as having a plus or minus on the other side. Okay, so normally solving this would be basically you just split it up into 2 problems. 5x minus 2 is 7x plus 14, and also negative of 5x minus 2 is 7x plus 14. So these need to be solved one at a time. They're 2 separate problems actually, and they have 2 separate answers. This particular problem does not actually ask us to solve it really. It says solving this equation gives us these answers. That's kind of weird. They told us the answer. And they're right about that, by the way. If you solve this first one, you really do get x equals -8. And if you solve this second one, you really do get x equals -1. So their answers are kind of backwards, but that is the correct x's. So I wonder why they would give them to us. Well, they want us to check them, you see. So I'm going to go ahead and plug my -1 into both sides of the equation. So I'm going to take this -1, I'm going to plug it in right there and right there. You see? So 5 times -1 equals 7 times -1 plus 14. And do you think parentheses are important? Yeah, usually they're really important. So this basically becomes absolute value of -5 minus 2. But absolute value of -5 minus 2 is the same as absolute value of -7. So this side is just absolute value of -7. The right side is not an absolute value. It's basically -7 plus 14, which is +7. Now, is this statement true, that the absolute value of -7 is just 7? And that is true. So that means that x equals -1 is actually a legit valid answer, because plugging it in gives me a legit true statement. Let's do the same thing. This time we're going to plug in -8 into both sides. So it's just kind of starting over. plug in the negative 8 here and here. So if you plug in 5 times negative 8 on this side, minus 2 absolute value, then you plug in negative 8 here, 7 times negative 8 plus 14. This is negative 42. And this is basically absolute value of negative 42. You'll notice that this is no longer a true statement. This is no longer a true statement because, technically speaking, this is false. Look, the absolute value of negative 42 is 42. How is that equal to negative 42? That's a lie. So because this simplifies to 42 and the other side is negative 42, this is not correct. So wait a minute, I thought that these answers that they gave us were both correct. No, not necessarily. You see, what happens is when you have this kind of equation, sometimes the answers you get in the end when you're solving these up here are actually false. One of them's false, or sometimes they're both false. Okay? So you have to check your answers. Some people say, well, I'll check my answers if I have free time. No, you have to check your answers because on a problem like this, there's only one correct answer, x equals negative 1. But your work will give you two answers. One's a phony baloney. So this one gives us x equals negative 8. This one gives us x equals negative 1. But this first one's a phony baloney, chicken macaroni. You should throw that one in the trash. How do you know to throw it in the trash? When you check it, it doesn't work. So this one's false. Okay, so the question says, is which, if any, solutions are extraneous? That means which ones are false. And we could say x equals negative 8 is extraneous. That means extraneous means false. X equals negative 8 is extraneous because absolute value, 5 times negative 8 plus minus 2, isn't really equal to 7 times negative 8 plus 14. These are not actually equal, so that's a phony baloney chicken macaroni answer. Okay, be careful with that. I'm going to show you something real quick. It's a computer thing, so bear with me. If you go to Desmos and you type absolute value 5x minus 2 is equal to 7x minus 14, you'll see something very interesting, especially if you zoom way out. You'll see that this only touches the x-axis once. See that right there? I can't seem to click on it today. I don't know why. Also, it's the wrong x. Did I type it wrong? Oh, I know why. This is a plus 14. I typed the problem wrong. So, but bear with me. Watch. You see how this only touches the x-axis once? It touches at negative 1. That's negative 1. So what is going on here? Well, because this is the only x-intercept, right here at x equals negative 1, that means that the only correct answer to this problem is x equals negative 1. X equals negative 8 is actually false. How do I know? Watch. Well, if you come over to x equals negative 8, do you see a graph crossing right here? I don't. All right, so that's why there's only one correct answer, not two correct answers. And zoom out as much as you want. There are not two x-intercepts. There's one x-intercept in this problem. That means there's only one legit answer. The other one's a phony baloney chicken macaroni. Okay, let's go now real quick to example 4. Now, here's where you have to be a little bit careful. When you're doing a less than or a greater than, you cannot just jump into a plus minus kind of thing. What you have to do is you have to imagine that there's a number line, okay? And on the number line is the 0. And then if you go 8 spaces away, you should find 8, or perhaps negative 8. So who's to say if the distance is, if the absolute value is 8, then you know that it's talking about negative 8 or positive 8. Because either way, the absolute value would be 8. Now, the 3x minus 4 lives either in this region between them, or the 3x minus 4 lives in the regions outside. So either it lives in the blue region or it doesn't. So which one should we go with? Well, when you see a less than here, what it means is traveling from 3x minus 4 to this origin is less than 8 spaces. So that means that 3x minus 4 is somewhere buried inside the blue region. How do I know that? Because when I measure from 3x minus 4 back to the origin, it has to be less than 8 spaces. That's what this statement is saying. So my red dots represent the possible places that I could place my 3x minus 4. I don't even know what number 3x minus 4 is. I don't even know what x is. But I know this. The red dot is called 3x minus 4, and it lives somewhere between negative 8 and 8. And this is how we solve these problems. We sandwich 3x minus 4 between the numbers negative 8 and positive 8. Okay, now, this is so easy to solve. I'm going to add 4 here, here, and here. So this is going to become negative 4. The middle is just going to become, I know it looks like a negative 4 there. I'm adding positive 4 in all 3 regions. So I'm adding it here, here, and here. So I basically end up with, in the middle, just plain 3x, because the negative and the positive 4 cancel. And then I get a 12 on this side. So notice how quickly that cleaned up, you know what I mean? I just added 4 here, 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 and boom, the middle part is already simpler. And now I'm going to go through and divide by 3 here, here, here. Why would I want to do that? Because now look at the middle. The middle is just plain x. Beautiful. And I've already simplified it to decimal for you. So the left side is negative 1.3, and the right side is 4.0. All right? So the endpoints of the graph are negative 1.3 repeating and 4.0. These endpoints should be drawn as closed dots, and the reason is we're using these symbols. So whenever you see this, you think you should think. Sorry, I can't write today. Whenever you see a less than equals, you should think closed. Closed. Okay. So go ahead and close them. So let's go ahead and put on here. I think negative 1.3 would probably be about right there. 4 is definitely right there. And we've already decided we're talking about this in between region. Okay, now this is technically called an AND problem. And the reason it's an AND problem is because if I put my finger right here, and there's my thumb. If I put my, there's my hand. If I put my finger right there, I can honestly say that my finger is greater than negative 1.3 and less than 4 at the same time. Like I can literally point right there, boom, and I'm satisfying both of these possible statements. So we call that an AND situation. Notice ANDs come together. Also, AND comes from this less. See? So you know how it's called less than, right? Just put a D on the end. Less than. Less than. See the AND? That always goes with the less symbol. All right, let's go do a greater than problem. See, this one's different because it's a greater than. Greater thans are a little bit harder. So what you have to do on these is imagine drawing 0 on here again, and then 15 spaces away, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. On this side is 15. And then 15 spaces to the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, is negative 15. So we have these two dots. One of them is at 15, one of them is at negative 15. That's what this number means. Absolute value is 15. Now, 5x plus 10 is the thing we wish to study. And it's somehow buried in here, but we don't know where. Oh no, I said that wrong. I said that wrong. Actually, it's not buried in there. It's buried outside, I should have said. Because watch, the distance from 5x plus 10 back to the origin is greater than 15. So I apologize, I said that wrong. The 5x plus 10 has to live outside here somewhere. I'm not sure which red dot it is, or it could be one of these. So sorry I drew it wrong at first. I was thinking of our other example. But the 5x plus 10s, if you count from there back to the origin, It has to be more than 15 spaces. So that's why it doesn't live in the middle region. It lives on the outskirts. It lives out on the boundaries. Okay, so let's take that to be the honest truth. If that's really the truth, then this statement right here is that 5x plus 10 would be bigger than 15 because it's on the right of 15. On the other hand, if the other one is true, then 5x plus 10 would be to the left of negative 15. So we get two possible statements. 5x plus 10 is smaller than negative 15, or 5x plus 10 is greater than 15 because it's on the right. And so those ones are a little hard, but you'll notice after I've done all the drawing and all the convincing and everything, actually the final result here to get the problem started was actually fairly simple. Look closely at what really happened behind the scenes. I just basically took away the absolute values, but I kept the greater than. And then I just wrote positive 15. But for the other one, you'll notice for the other one, it's a little different. I didn't write 5x plus 10 is greater. I wrote 5x plus 10 is less. And then I used a negative 15 here. So if you preserve the greater, then preserve the 15. But if you deny the greater, if you break down the greater and turn it into a less, make sure you use a negative 15. Okay, now both these problems are pretty easy to solve because we've been practicing solving. So here we go. It's two problems in one, remember. So we start with 5x plus 10 is less than negative 15. We basically subtract 10. Now we have 5x is less than negative 25. Then we divide by 5. And we get x is less than negative 5. Okay? This is an OR problem. I'll explain why later. Then we have 5x plus 10 is greater than 15. Totally different problem. We still subtract 10. But we get 5x is greater than 5. Then we divide by 5 here and here. And we get x is greater than 1. So my answer is x is greater than 1. Or x is less than negative 5. Let's draw a picture of that scenario. When we say x is greater than 1, what we mean is go to 1, draw an open circle, but shade to the right. That was very sloppy. There we go. When we say x is less than negative 5, we mean go to negative 5 and draw a circle, open circle, and go to the left. So what we're claiming now is that x is basically something over here or something over here. Either x is bigger than 1, which means it's on this side, or possibly x is less than negative 5, which means it's over here. Since you can't put your finger in both places at the same time, you must use the word or, because it's two separate locations and you can't exactly put your finger on both. Okay, that's that. And then you'll notice this we're not going to do. It's pretty cool stuff, especially if you're interested in technology and factories and building things and measurements and all that. But we just don't have time. So let's do a quick lesson check. When is the absolute value of a number equal to itself? So that would be like saying, when can you place something on the, where would you put something so that the distance is the same as the coordinate? And so basically it's kind of a trick question. If you go over here to like 1.5, the distance is 1.5, right? If you go over here to 3, the distance is 3. If you go over here to 16, the distance is 16. Okay, so basically it seems like it works whenever you pick a positive number, right? But when you go to the left side, that's not true. Watch. If you go to negative 1.5, the distance is positive 1.5. See? If you go to negative 3, the distance is positive 3. So in which scenario do we have the position and the distance being equal? That only happens on the right. On the left, you can't say that negative 1.5 coordinate is the same as positive 1.5 distance. So I think the basic idea on this problem is to convince us that only positive numbers make this statement true. Or maybe if x is 0. So they're going to ask us a few questions, and by the time we're done with these 4 questions, we will have our answer. The absolute value of 0 is definitely 0. See? Input same as output. When a number is negative, its absolute value is equal to its opposite. So for example, if the number is -3, like we said, the output's its opposite, +3. When a number is positive, the absolute value is equal to itself. Like we were saying, if you make your number 3, your distance is 3. So it's equal to itself. And then now we can answer the question. Oh, I realize now we should have written its opposite right here. And its self right here. So this one is itself, and this one is itself, but this one is not itself. Okay, so final answer would be like this. If x is 0 or positive, then absolute value x is equal to itself. That's a great way to write it. And another way to write this would be if x is greater than or equal to 0, that means 0 or positive, then absolute value x is equal to itself. Sorry for the noise. So you can write one sentence or both, or I don't care which one. Okay, they're the same meaning. Check off the words absolute value, distance from 0. Graph means you've already drawn on your number line. Inequality means less than, greater than, or less than equal, greater than equal. And equation just means something equals something. That's called an equation. How well can you use absolute values to solve equations and inequalities? Would you say that you're at a 2 level, which is low, and you need to review? Or are you at an 8 level, which means you're almost ready for my quiz next week? All right, that's it.